Alright guys, as you might saw, today we are making fractals in Blender. The whole node group is entirely based in geometry nodes, so it's fully procedural. Also, the biggest advantage of this method is that it works with every object and with any surface. So enough talking, let's begin. We will start in geometry node section, of course. The only object that we'll be using from the default scene is the cube, so we can delete everything else. After that, we will convert our whatever object we choose into curve. Then add resample curve node. The count is the amount of points that the node will be resampling to it from its original geometry. Just for a start, you can set the number to 30. For the next step, we will add instance on points node. That is the core structure of this project. And as an instance, you can use any primitive object or use one from your scene. But I strongly recommend using only primitives, because the computing process will be very demanding for Blender, and your computer will most likely crash or freeze, so don't do that, use primitives instead. Also, do not use spherical objects, because they look the same from every angle, which is something we need to avoid in this workflow. I will use a cylinder with 16 vertices, 0.15 meters on the radius and 2 meters in depth. Now this is what you should end up with. It looks weird, but the node group is working. If you decrease the count, you can see that we are instancing the cylinder on every point. So if we increase the point count, the density increases as well. But we don't want to rotate all of them in the same direction. Let's start with adding a curve tangent and plugging it into the rotation. This already does something, but we need to add a line Euler to vector and plug the tangent into the second vector input. Choose z-axis, and for the pivot you can use either y or x. It doesn't matter too much, but the rotation will be different. For the right rotation, we need to add position node and vector math node with multiply operation. Plug the position to the vector multiply node, and from there plug it into the rotation input. As you can see, nothing changed so far, because we are currently multiplying with 0. So add a value node to drive the whole vector and increase the value. You can see that it creates this infinite abstract loop. That looks cool, but there are still things we need to fix. The whole object looks ununiformed, and we can clearly see the separation between individual instances, which is what we don't want to have. So to get rid of this separation, first we need to realize the instances, to convert them into the actual geometry. Second, we need to remesh the object. We can do this easily by converting mesh into volume, and then convert the volume back to the mesh. This will get rid of the separation of the cylinders, and it will also allow you to control the resolution with the voxel size. But the best part about this method is that you will get different results with different objects, so you can have unlimited variations. If you want to have the rotation uneven and more randomized, instead of multiplying a value, you can multiply texture and animate it. Now, to avoid a misconception, I wouldn't call this exactly a fractal, because fractals are more likely infinite pattern based on repetition, but visually it's pretty close to it and it sort of behaves like fractal. So I say this because I don't want hateful people in comments saying that this is not a fractal. Listen, I know this is not a fractal, but I try to replicate the visual similarities. I say this especially for the people who likes to write rude comments under every video. But despite this detail, I hope you learned how to make this abstract fractal-like pattern. There are also useful videos on my YouTube channel that you might find informative. If you like this workflow, consider subscribing to starting a YouTube channel. I will appreciate that, and I will deliver only the best content I can possibly make for you. Until then, see you in the next video.